of ABB's robotics division, Marc Segura, is back, and he's about to take us on a virtual tour of one of ABB's newest facilities. But before we don our high-vis and safety goggles, I wanted to know about some of the biggest improvements we're now seeing in factories.
These factories, they're taking even next step on safety. So they're becoming even fantastic workplaces for people to work in. And of course, they deliver higher productivity. But what's coming more into the real modern factories are two key things. The first is flexibility, and the second is the digital part of that. Flexibility, because you need to imagine these factories can produce almost on real time, very different products to be really responsive to the market trends of consumers liking a product or a different one, or preferring to buy online or to preferring to go to store. So all this flexibility delivers resilience to the producers is paramount for a future where everything is basically fast, dynamic, and ever-changing. And the second part of that, they are really, really digital, meaning that anything that you have physically has a digital equivalent, a digital twin. And that is, of course, very necessary for the foregoing. I mean, if you want to be responsive and, let's say, feed anything that happens in the market into the factory, you need to do that through digital means, meaning you capture any customer insights and you immediately give different orders, different commands to the factory, and you can see what the factory is doing, everything digitally and everything in real time. So you can imagine this factory is really like digital birthplaces of the products, where you basically get from the customers what you want. You create kind of a DNA, and then you have the product going step by step from robot process to robot process being created around with this digital recipe, which could be the DNA. And then finally, the product going through different process steps is kind of born and goes out of the factory door.
Obviously, this is the Robot Podcast, so we won't be able to visually see these mega factories. But Marc, humour me a little bit. Could you take us on a little bit of an audio tour of a mega factory? And if you did, what would be our first stop?
So join me. Let's walk through. The first step is where the goods are coming into the factory. So this is the inbound warehouse, okay? The inbound warehouse is this building you see here, which is tall, has lots of racks and shelves, and I will explain you how it works. So we are gathering from our partners and suppliers different parts, components, and subassembly to create robots. What does it make a modern digital automated warehouse? Well, you should imagine a very tall building with lots of racks, and then in between the racks, you have automatic devices that go and pick a certain pallet or pick a certain tote and bring it down, either to be refilled or to be picked to create then the kits that will go into the assembly lines. So this massive structure with these automated cranes and shuttles is very dense. You have no space because you really want to minimize the volume you occupy, but at the same time is very flexible. We have more than tens of thousands of SKUs. SKU is a stock keeping unit. It's a concrete component number. So it's the tag for every different component. And everything is digitally tracked and followed. So we know exactly what is in that warehouse, where it is stored, what is the consumption of a certain SKU, so you can automatically ask the supplier to refill. And at the same time, from the assembly lines, you can pull any demand to go to the assembly lines.
So you have these sort of massive, I suppose, component racks, and the robots will be like, to build this, we need this one and this one and this one, and they automatically retrieve them, get them in one place, ready for the next stage.
Exactly. It's a bunch of racks, shelves with pallets and totes with components inside. But this used to be, and it is already in many factories and warehouses, totally manual, meaning that you need forklifts, you need lifts to reach a certain height on the shelf, and then you are having printed labels to know what's in each box, and then you manually update if you pick one or two. All that's gone.
Okay, so that's the automatic warehouse as our first stop. And then where do we go to next?
So you see now we stored and we picked all the components we need to create a robot, and that we call kits. So let's go to the kitting lines. You will see how we put together all the component bundles, the kits, and how they are then transported to the assembly lines. So in the past, again, where the warehouse was, again, a manual thing, you would have a need of a very big space where people with forklift would have brought pallets and totes, and you would have typically people then building up these kits, which is basically to take different components from several pallets and totes and put them into one tote, the kit tote. Typically, the material handling from the warehouse to the kitting zone was done by fixed conveyors. All that now has changed to one element, and those are the autonomous mobile robots. You can imagine that the automatic warehouse is bringing things, let's say, to the picking stations. You have robots picking the components and building up that kit tote. And that kit tote now can be directed by software to the exact process step at the exact moment with the mobile robot. So where we had lots of stuff laying on the floor with a lot of activity, now it's a kind of an empty highway where you have the AMRs routing exactly at time when they are needed to bring the kit to the assembly line. So we don't talk now about just in time, but we talk about just in sequence through the means of autonomous mobile robots.
Of course, with people, you can't be doing that. You can't be like, oh, now I need this bit. Oh, now I need this bit. Now I need this bit. But with the AMRs, you can.
Of course, you can do everything with people, but here we talk about, is that safe? I mean, how fast can you do it? How dynamic, how that accurate can be? Here, again, none of this is not possible, and I insist on that, if you have a complete digital replica, a parallel digital twin of everything going on. Because the connection of your control system and your company demands and company supply chain versus the hardware has to be in real time connected. And that happens only if you have a complete digital twin of your factory.
And so are there other tasks that the AMRs help with as well?
Yes, the AMRs are, for example, helping to unload the trucks and bring the stuff from the trucks to the warehouse. Then we talk about the warehouse, and then from the warehouse, they are feeding the lines with kittings. But we don't stop there. Going back to the DNA sequence, in some of our lines, every individual product is traveling the assembly line mount on top of an AMR. So the AMR has, let's say, a cover plate where at the beginning there's nothing. And then it goes to step one. You start to build the robot. Then it goes to the process step that the system dictates based on what type of robot. And then you're building on top of the AMR. So again, you're not following a straight line like in the past with a massive conveyor crossing the line. Now the AMRs are bringing the product from process step to process step in very different pathways, depending what product has to be built, depending what this recipe, this bill of materials, this DNA is calling to be needed to assemble, then the AMR would bring the product to every process step.
From there, we go on to our third stuff, isn't it? Which I believe are called the controller and Rioja lines. And I am quite partial to a glass of Rioja myself. But I assume more happens here than just drinking wine, doesn't it?
Yeah, by the way, I'll never know what this name came from. I do also like a good glass of Rioja. The Rioja line is the line where we assemble the small robots, the family of our smaller robots. And also, besides it, we have the controller line. The controller line is where we assemble the electrical and control cabinet that commands and gives power to the robotic arms. So come, let's see how these two things are built. So this controller line are complex, but we have managed to design almost totally robotized assembly. And what happens there? Well, we are getting first the assembly of the envelope. So we are building the walls of the cabinet and putting that together. So you have that box, okay? And then that box travels station by stations where the robots are then inserting different electronic kits. Some will take the computer board and insert it. Some will take the power drive and insert it. And also, very interestingly, the robots are doing then the testing. So you have robots, for example, connecting a cable with a plug to a testing device, and the robot is measuring the testing result, and then it's deciding if the quality is good enough and rejecting or continuing to the next process. So you have a bunch of robots that are step after step inserting the different electronic models to build up a complete robot cabinet. And in this line, we can build up more than 7 type of controllers that go from very small, which we call E10, to the very large ones to run the large robots. So it means that we're going just to go to the process steps that we need for any controller, depending on which product it is.
I think we all know the reason why it is important to test these robots before they go out into the world. But could you explain from ABB's point of view why this testing is so important?
Mega factories are flexible. So you will run a large number of product and product variants, and you would be very flexible and responsive to listen to the customers and change your product and continuously be on top, let's say, of the customer need. That means that the quality systems you must have in place have to be very strong, because you're not going to have 3 years to perfection your manufacturing. It's going to be perfect every single day in small batches. That calls for automated quality inspection. And that's what, again, we are embedding in mega factories. It's not only the automatic assembly, but it's the automatic quality control. And here again, for example, we have different elements. In the Rioja line, we are using, for example, artificial intelligence and sensors to make sure that when we are screwing some screws to assemble gearboxes or to assemble some mechanical parts, we have the exact force. So we're tightening the bolt so it will never get loose. It's not too strongly tight that you break the part. So that we are doing because we're adding sensors to the robots while they do the screw driving. And we're using artificial intelligence, which has been trained to understand what is the acceptable force when you do that. So every robot then has its digital twin, and we can track how tight the bolts were, if the controller connection worked well when we plug the plug. There is also a digital file that is the quality test of every robot that is individualized and in real time produced process step after process step.
In my 40 years of being alive, I don't think I've got the force exactly right.
Yeah.
That's exactly the type of thing that AI can learn so quickly and can get right no matter what the components are made of, and and adjust it where it needs adjusting.
And there are many other elements of automatic quality inspection. For example, you can think about paint quality, that you make sure that you're painting with the right amount of paint, that you're keeping the right amount of temperature, humidity in the painting room. That's one element. For example, when you weld, and we have arc welded parts, we also have robots that have cameras that have been trained to understand what is a good welding, because that you only can do with AI. I mean, how do you find that the welding is good or not? Well, basically you need someone to tell you with a number of rules, heuristic rules and experience, and some mathematical rules, but everything blended. You need AI to understand what's a good welding or not. Now, today, this is possible, and we have robots that are welding, and at the same time, right at the same moment that one robot is welding, another colleague, another peer robot has a camera, and it's recording that welding, and the ML is telling, hey, guy, you're welding right or not. And if you are not, the robot will self-correct the trajectory, because the quality robot is going to tell him, hey, you are deviating 2 millimeters in this direction, you better correct off your trajectory. So that is already possible and happening today.
Okay, so we've gone from the automatic warehouse to the kitting line to the Rioja and controller lines. And I suppose the only thing left there is the sort of packaging and dispatch, and then off they go. How do you see, and where do you see mega factories going? Over the next few years, are we just going to see this growth and expansion in mega factories?
The next step is that this becomes kind of the mainstream thing, that this becomes really the blueprint of any factory. If you imagine those factories even more in the future to be totally sustainable. Totally sustainable because the technology will optimize everything end to end, not only, let's say, the more obvious CO2 emission part of that, because you can think about solar power, energy, you can think. It's more what I stress in the production process. That's where a lot of waste happen. When you are doing the things wrong, when you're storing too much, because storing too much means transporting too much, etc., etc. So I think there's also a very great future for production to be more sustainable and a better workplace, that we are just kind of imagine a little bit what technology will be able to help us and enable us to dream about.
Marc Segura, president of ABB's Robotics division. And what an incredible insight into what goes on in their brand new robotics mega factory. To go on that tour and just see how things are being streamlined so we can produce what we need in the most efficient way, not just in terms of using people where they should be used and in terms of the time of the production, but also in terms of ways that we can do it that help the planet and the emissions as well. Fantastic. Finally, let's return to our global futurist and professional optimist, Jim Carroll, for his predictions and thoughts on the future of factories and manufacturing.
It has to be the next generation manufacturing engineer coming into the workplace. Look, I was with one manufacturing company in St. Louis, and, it was an old foundry, traditional 150-year-old manufacturing concepts. But they took me into what they called the Xbox room. And in the Xbox room were 3 young manufacturing engineers, 25 years old, with a whole bunch of gear, 3D printing technology, digital twin technology, heads-up display technology. And in essence, what this organization was saying, look, we understand the digitization of the factory is critical. We understand the industrial Internet of Things is going to be critical. We understand we have to master 3D printing technology. We don't understand it. We don't have the insight. But here's a budget, here's some money, go and play, figure it out. And these young engineers, they called it the Xbox room. And it was their manufacturing laboratory to take them into the next generation of manufacturing. Not a month later, I was with a trucking company, and they had what they called the Google room. And it was 4 young trucking individuals with a lot of gear, a lot of money, a lot of toys. And they were figuring out, the next generation of supply chain in trucking. The typical truck today contains more technology than a Cessna airplane. And that's what these young individuals are doing.
Gosh.
Yeah, I think the key thing is this next generation, they're digital, they're wired, they're collaborative. They don't know a world without technology, and they are a force to be reckoned with. And as they take over senior executive positions, as they come to design the factory of the future, as they come to look at robotics, as they look at how do we change process to be more agile, if we thought the world was fast before, it's just simply going to become crazy fast as they become more involved over time.
So with this increased use of tech, the progress of digitalization and the use of robotics, how do you see humans fitting into all of this? Where will the future leave us human workers in factories?
The typical machinist today has to be able to do trigonometry in their heads because the sophistication of the process has become so complex. So it's the disappearance of the routine traditional jobs, and it's the appearance of new, very sophisticated, highly advanced, highly skilled work that is taking the place. And where we are failing is that we aren't doing enough to train those people. We aren't doing enough at the community college or university level to ensure that we have those skills. We aren't doing enough to ensure that we've got an innovation mindset within our factory to ensure that we're taking advantage of some of those skills when they come in the door. So there is a very fundamental and transformative shift occurring in the world of manufacturing today.
So it's obviously quite an exciting time, and I know the past 5 years, the past 10 years has changed so much when it comes to the use of technology within manufacturing. But what excites you most about the future of the use of robotics and AI in factory settings?
What is happening right now is a whole bunch of trends are coming together all at once. Digital twin technology, robotics, artificial intelligence, advanced skills and capabilities, rapid prototyping. We're entering what I call the era of acceleration. Combine that with a greater willingness and understanding that we need to be more agile, we need to be more flexible, we need to bring product to market faster, we need to design faster, we need to deal with the reality of the collapse of product life cycles and, a world in which everything is becoming digitized. You bring all that together, the world is going to speed up. And to me, as a futurist, the fact that the world happens faster means that opportunity happens faster. And so if we can align our organization with that agile and flexible mindset to take advantage of tomorrow, not view these trends as a threat, but to view them as an opportunity, that's where I find such tremendous potential and excitement with robotics and with AI and with everything having to do with manufacturing.
Some final thoughts and crystal ball gazing from global futurist and keynote speaker Jim Carroll. Gosh, what a future we are going towards. The planet is put into consideration where it comes to manufacturing, and we're doing things in the most efficient way. I, for one, am really excited about the next 10 years in manufacturing. But unfortunately, that is it for this week. I would like to thank my guest, futurist Jim Carroll, and of course, ABB's Marc Segura. Next time, we delve into how robotics is helping us feel better, quite literally, as we meet some of those who are at the cutting edge of robotics in healthcare, and we look at how robots could well be looking after us more in the future. I'm Fran Scott. The Robot Podcast is a fresh air production for ABB. The producers are Gray & Seaman and Izzie Clark. And don't forget to follow now for free wherever you get your podcasts so you never miss an episode.
Part of the ABB Decoded series.